Welcome to a brief introduction to probability. In this video, we'll go through some of the basic concepts of probability. Let's get started. You might be wondering, what is probability? In math and statistics, the probability of an event represents the likelihood it will occur. You might hear a common phrase like there's a 40% chance of rain today, or there's a 5% chance that your next flight will be delayed. Probability is used to express the likelihood that those events will occur. There are two main types of probability. Experimental probability is found by conducting experiments. Theoretical probability is found using mathematics. So, for example, we could learn about the probabilities of rolling a six-sided die by actually carrying out a physical experiment where we roll a six-sided die several times. Or, as you'll see in this video, we could think about the likelihood of certain events by thinking about the different outcomes that are possible when we roll a six-sided die. Let's take a look at basic theoretical probability. In basic theoretical probability, the probability compares the favorable number of outcomes to the total number of possible outcomes. We usually write this as a fraction. So on the left-hand side, you can see P of E. We interpret that as the probability of event E is equal to the ratio of the favorable number of outcomes to the total possible number of outcomes. So for example, let's use our six-sided die, and let's calculate the probability that we roll a 1. So if we think about the favorable number of outcomes, well, there's only one way to roll a 1. I literally roll the number 1. But for the total possible number of outcomes, there's actually 6 because the die could land on a 1, 2, 3, 4, 5, or 6. So in this case, the probability of rolling 1 is 1/6. There's one way to roll a 1 out of 6 possible outcomes. Now let's talk about the sample space and sample size. These are common definitions that we use when talking about probability. The sample space is the list of all possible outcomes in an experiment. So continuing with our die example, our sample space would be 1, 2, 3, 4, 5, and 6. Those are all the possible numbers we could roll if we roll a single die. The sample size is the number of possible outcomes. So since there are 6 numbers that the die could land on, our sample size is 6. We usually represent the sample size with the letter N. A probability distribution is a table that lists each possible outcome with its associated probability. In our die example, if we list all of our possible outcomes, meaning the numbers 1 through 6, on the left side of our table, and then the probabilities on the right, this table will be considered our probability distribution. All the outcomes with all their associated probabilities. So we already calculated the probability of rolling a 1 was 1 out of 6, or in other words, 0.167. We could continue on in this fashion if we wanted to find the probability of rolling a 2. There's one favorable outcome, rolling the number 2, over 6 possible outcomes. The probability of rolling a 2 is still 1/6 or 0.167. Continuing in this fashion, the probability of rolling a 3, 4, 5, or 6 is all 1/6. In this probability distribution, every outcome is equally likely. Now, that's not always the case. It just happens to be the case for this scenario. Let's talk about some probability facts, and I'm going to reference this probability distribution as we go through here. Probabilities are always values between 0 and 1. And every probability can be written as a fraction, decimal, or percentage. So if you look at the probabilities on the right side of this table, I've written every probability as both a fraction, 1 out of 6, and its decimal equivalent rounded to 3 places, 0.16. Now decimals we can think of as a percentage as well. So that means that there's roughly a 16.7% chance of rolling a 1 or a 2 or a 3, etc. So usually in statistics and in math, we typically tend to favor probabilities written as decimals. But when we communicate in English, we usually convert those decimals to percentages. So going back to the previous example, there's a 40% chance of rain would mean that the probability was 0.4. Probabilities describe the likelihood of an event. So the closer the probability is to 1, the more likely it is to occur. The closer the probability is to 0, the less likely it is to occur. When a probability is equal to 0, we say that the event is impossible. When the probability is equal to 1, we say that the event is certain. So in the case of rolling a die, let's say we wanted to calculate the probability of rolling a 7. Well, that probability would be 0 since that's impossible. The die doesn't have a 7 on it. And one last thing, the sum of all the probabilities in a probability distribution is 1. If you added up all the probabilities on the right-hand side of this table, 1/6 plus 1/6 all the way down to the bottom, you would get 6 over 6, which is 1, or 100%. And that's because if we roll a die, it is certain that we will roll a 1, 2, 3, 4, 5, or 6. Time for a few more definitions. Events and event spaces. An event is a set of specific outcomes for an experiment. Usually an event is a subset of the sample space. Let's look at an example where our event is we roll an even number. The event space, which is different from the sample space, is a set of outcomes that make up an event. If our event is we roll an even number, then our event space would be 2, 4, or 6. Sometimes it helps to draw a Venn diagram so you can visualize the event space. So let's continue with our event E, where we roll an even number. If I wanted to draw a Venn diagram, I would start off by drawing a large square. That large square represents our sample space. Then we'll carve out the event space for event E, which was 2, 4, and 6. Now outside that circle, we're going to have the outcomes that are still in the sample space, but not in event E. So in this case, outside of event E, we'll have the numbers 1, 3, and 5. Those are possible outcomes, but they're not part of our event space of rolling an even number. These values that are in the sample space and not a part of event E are known as the complement of event E. The complement of an event E is usually written E with a little apostrophe, or sometimes you'll see it written E with a bar over it, or E with a superscript C for complement. The complement of an event contains all of the outcomes in the sample space that are not in the event. So like we said, if event E is we roll an even number, then E contains the numbers 2, 4, and 6. The complement of E is really the event that we don't roll an even number. In that case, E complement would be 1, 3, and 5, which is the odd numbers. So our event E is we roll an even number, 2, 4, 6. Our complement is we don't roll an even number. In other words, we roll an odd number, 1, 3, or 5. Now, if we calculate the probability of event E, there are 3 favorable outcomes, 2, 4, or 6, over 6 possible outcomes, 1 through 6. So 3 6 reduces to 1/2. So the probability that we roll an even number is 1/2. That should make sense because half of the possible outcomes are even numbers. Now let's calculate the probability of E complement. What's the probability we don't roll an even number? Well, in this case, there are still 3 favorable outcomes, 1, 3, or 5, out of 6 total. So the probability of E complement is still 1/2. And notice that those probabilities together add up to 1. Because one of those things is certain to happen. I'll either roll an even number or an odd number. This is an important property of complements. For any event and its complement, if we add the probability of the event and the probability of its complement, it will equal 1. The reason why this rule is important is because if we use algebra to rearrange this rule, we create what's known as the 1 minus rule in probability. This says that the probability of a complement of an event is 1 minus the probability of an event. Or in other words, the probability of E complement equals 1 minus the probability of E. And let's take a look at an example of how we would use this. Suppose 13% of Americans smoke. If you meet an American at random, what's the probability that they smoke? Well, if our event is the person is a smoker, the probability that a person is a smoker is 0.13. Notice how the question communicates the likelihood of a person being a smoker as 13%, but when we write that number as a probability, we want to convert it to a decimal. Okay, now let's take a look at the second part of this question. What's the probability that they don't smoke? The relationship here is complementary. Either a person is a smoker or not a smoker. So the probability that we meet a person and they're a non-smoker is 1 minus the probability that the person smokes. But we know the probability that a person smokes is 0.13 or 13%. So to find this probability, we'll take 1 and subtract 0.13, and that gives us 0.87. That means that there's an 87% chance that you meet an American who is not a smoker. That's it for this video. Thanks for watching.